This is the Rocky Flats Cold War Museum Oral History Project. I'm interviewing Fred Fraikor. I'm Hannah Nordhaus. It's the 16th of June, 2005, and we're at Fred's office at the Colorado School of Mines, where he teaches. So, Fred, to get started, if you could just tell me a little bit about your background, where you were born, what your parents did.
Okay. I was born in a steel town called Duquesne, Pennsylvania, which is one of the suburbs of Pittsburgh. My parents, although my dad grew up here, were of Slovak. Back then it was Czechoslovakia origin. My dad, like all the other immigrants at the time, would run back and forth. They'd make their money in the coal mines and the steel mills. And then he'd go back to Czechoslovakia, buy up land, and come back here. What they didn't realize is the communists would then confiscate the land, which is why I'm not a big baron and land baron at this point. But my mother, he brought my mother back here in 1936, just before World War II. The Nazis invaded. So I literally grew up in a Slovak-speaking culture in a steel town. The enclaves were set. You had a Polish hill, a German town, etc. And so when I went to kindergarten, I didn't really know English. And we were mentioning the Carnegie Library, because this was a Carnegie steel mill. I literally learned to read well in a Carnegie Library. And I know you tell your grandkids now you walked 5 miles in the snow, and back then, they say, oh yeah. But we did. It was a wonderful Carnegie Library, and by coincidence perhaps, I ended up going to the Carnegie Museum, where I developed an interest in science, and every Saturday I'd ride the streetcar, the trolleys here I guess, to the Carnegie Museum in Pittsburgh, and really began being interested in paleontology, the usual thing, dinosaurs that kids do even back then. After that, and after graduation from high school, I actually went to what was then Carnegie Institute of Technology, is now Carnegie Mellon University, and got a degree in metallurgical engineering. I did work in a steel mill. My first encounter with the nuclear industry was as a summer student at Carnegie Tech, working in a welding thing at the Westinghouse Atomic Power Plant, which is just outside of Pittsburgh, where they were building the first nuclear power plants for the nuclear Navy at the time. And everything you heard about Admiral Rickover is true. He would fly in, look through the desks, everything. I mean, it was quite different for a junior in undergraduate school. But I did work in a steel mill as a laborer, was a member of the AFL-CIO, working as a laborer in the summers in a steel mill and as a management trainee later convinced me that that's not what I wanted to do. People don't realize how it was to work in a steel mill in those days. But I did go on. I had 2 years of active duty as an ROTC officer in Fort Monmouth, New Jersey. After that, I went back and to graduate school, because again, I wasn't going back to the steel mill. I was married to a Carnegie Tech co-ed at the time when I was in the Army, and Signal Corps, typical wedding with swords and the whole bit. Came back, went to Ohio State University, where I got my PhD in metallurgical engineering. After that, one of the interviews that I had during the summer of, well, it would have been a year before, so would have been about June of 1965 or so, I came out here for an interview. Now, you couldn't even go on the plant at that time for an interview, so they took me around Arvada and showed me housing and everything else. But of course, I saw the mountains. That was it. It looked like a wonderful place to raise children. 2 of my children were born at Ohio State, and 1 here shortly after I came here. So I interviewed and got a position with Rocky Flats as a scientist in what was then the Physical Metallurgy R&D group under Dow Chemical, which was fascinating. My first task really was to do transmission electron microscopy on plutonium. I was stationed in what was Building 779 at the time. Relatively new building. 779 was the research and development center, so to speak, for the plant at that time. And understand Dow Chemical, and again this is in 1965, it was December of 65, so at that point Dow was heavily involved in striving for excellence in science and engineering, partly because that's their tradition as a chemical company. They had research facilities, and the people they had here we communicated, but mostly because the laboratory personnel, obviously we had to work and interact with Los Alamos, Lawrence Livermore, Berkeley, and Sandia Livermore for the most part. And these are, of course, PhD scientists, some from the Manhattan Project, and that, so you're talking to a physicist, you should have the expertise, and that's how Dow felt they wanted some of the best. The physical metallurgy group that I came in, and I think it was within 8 months or so, I ended up being the manager of the physical R&D group. The other two went to Midland, were promoted into Dow Chemical's Midland corporate headquarters. So I ended up with this group, the Physical Metallurgy R&D group in the late 60s, was basically consisted of about, roughly 20 people at one time, half of whom were PhDs, working on the physical metallurgy, that is, the understanding the relationship between the structure and properties of the various materials at Rocky Flats. It wasn't just plutonium, because there was a separate plutonium metallurgy group, but it would be looking at everything: beryllium, the stainless steel components, the exotic alloys that they would come in, and so on. Our thing was to do research and publish the unclassified portion of that. So it's just like any other research or research institution at either at a company or here at the university. And in fact, we often had Q-cleared faculty from School of Mines and other universities come in and do consulting for us. So that was the level of expertise. This is not production, but much more into the research orientation. We all published papers, gave presentations at scientific conferences, and so on. I would say that in this group, as again, half were PhDs, another half were what are experimental operators. These were the union and hourly people, and they were outstanding. I mean, as technicians, I've never seen a better group of individuals that basically did a lot of the handling. They did the data extraction, so forth. But in our group, a lot of the experimental operators were people whose career was either interrupted by World War II, they were community college graduates or so forth, but they had to have fairly extensive, for the time, knowledge of algebra, math, etc. You didn't want them to mistake 100 grams for 100 kilograms. And so they were, you can't give enough credit to those people in terms of supporting for engineers and scientists. Looking at in terms of that group, the environment was that, as I mentioned, of science. I was the first, certainly, my experimental operator and I, to examine plutonium in a transmission electron microscope, and published it. And also in terms of beryllium, ingot sheet beryllium was the big thrust at Rocky Flats in terms of quite unique way of making and casting beryllium. There was a separate beryllium research group, but we provided support to that. And you have down here how did the difference between the contractors. Let me mention that I worked there, worked my way up to being the acting director of material science. I left in 1972, something like that, to become the first dean of engineering technology at Metropolitan State College. At that time, there was no Auraria campus. My office was down there in an old Dodge auto dealer's thing on Colfax, and it was quite different. But anyway, so I came down there. At that time, they were looking to integrate the University of Colorado in Denver, the community college, and Metro as a four-state intermediate university. Politics being what they may, they pretty much grew up on the Auraria campus, still separated. But I left there because I should go back. My wife married, as I said, we married in Fort Monmouth, New Jersey, but while I was in the service. But after 3 children, I really prodded her to go back to school and finish her degree, which she did. Got a fellowship and got a PhD in physical anthropology at CU. So she had her first teaching job in Wichita, Kansas, went there, and I ended up as a visiting scientist at the Smithsonian Institution in Washington, D.C., of course, where I worked on archaeometallurgy, and that's one of my fields of interest and expertise, and I'll talk a little more about how that related when I came back. After my stint as a visiting scientist, I had an offer from Lawrence Livermore Laboratory to come back and run their plutonium research. But instead, I thought Colorado was a wonderful place. We had fond memories of it and so on. So came back here, essentially at the beginning as a physical metallurgy R&D group. Now what I discovered, of course, Rockwell International had taken over as contractor from Dow Chemical in that interim where I was gone. Dow Chemical, as I said, worked on a building-to-building basis. They used building superintendents because it was just like a chemical company. It didn't matter if it was plutonium or if it was salt. What came in on one side of the building and went out on the other side as a product or a compound or whatever, that was the building superintendent's bailiwick. And he was, in fact, the lord and manor of the house. He controlled every aspect. He was generally the senior manager in that building. Our building, for example, had 779, had the physical metallurgy R&D group, it had adjoining R&D group, it had small physics group and small chemical engineering group. All of those had laboratories. Our offices were directly across from the laboratory. So we were in the building. You had a lab, which of course had the negative pressure kinds of things in the building, had the pressure and so on. But the offices, the engineer scientist would walk out, open the door, put on his booties, etc., and they were always, back then we were in lab coat kind of a situation, and we worked with small amounts. But again, looking at the metallurgical properties of all of the materials at the plant. When I came back, though, as I said, the operations management for Dow Chemical was that of building superintendents, a hierarchy, a direct reporting. If you worked in the building, you were doing those programs, etc. Came back, Rockwell International, of course, being an aerospace company. Their focus was what at that time was called program management or matrix management. And so what you did, you found out that they worked on the basis that, gee, somebody like the president of North American had all the people, but all the money rested with an individual who had all the contracts for the space shuttle, let's say. And so you charged the time to the space shuttle. So they did the same thing at Rocky Flats in the sense they formed program management teams. You then worked in matrix where, let's say you were on the W76 program, your engineers did that. Realizing that, and that it was no longer like a publish or perish kind of an atmosphere for the research and development group, one of the things that I instituted was much more of a management or a manufacturing support to production. So, because we had all of this expertise, I had some of the best engineers and scientists that were in the weapons complex. I have no question about it. I mean, they published, they were the equal of anybody at Lawrence Livermore or Los Alamos. They were outstanding. We had people from Yale, we had people from Stanford, and so on. But now we provided a lot which was in failure analysis, where you had production problems. Cut that off.
Sure. You want me to turn it off?
No, I just didn't want you to
Okay.
hear the phone. I better look at this again because I'm still on.
Contracts. That's fine. We're working our way through. We can just sort of backtrack to questions that.
Okay, the security and discussing work with the family.
You say sort of keep going through your career, and then we can sort of fill in the holes.
Okay, thank you. Yeah, you have to nudge us old guys along. Okay, back to the business of matrix management and program management, and the fact that I shifted the strategic direction and thrust from research into more of a development, support, failure analysis, and so on. But the physical metallurgy group was pretty much the same as when I came in. Now you have a question here about in terms of the environment, security, and so on. Because we were all roughly the same, all graduate, in their late 20s, things like this. All the guys had sports cars, for example. I mean, that was the big thing. So I had a Fiat 124 Sport Spider, so my mechanical engineer had to get the same thing. Another one had to try. That's the 70s kind of a atmosphere. So it was a lot of esprit de corps, camaraderie. We would have bridge at lunchtime in Building 779. I don't even remember how to play bridge now, but that was the thing. You got together. We had social things. The managers got together for bridge. I think once or twice every Friday with the spouses. Rule being you couldn't play with your spouse, so there were no marital arguments. But that was, again, one of the things that it was very close in terms of these small R&D groups, and you got to know everyone almost socially, picnics and so on. And there was a question in here about women. In my, let's say I had half, say 12, at one point I had 12, I made a point of hiring women engineers, and it was, the premise was simple back then. If she were female and she was in a profession as a scientist or as a doctor or something like this, she probably wasn't just as smart, but probably smarter than the men on the average, because she had a lot more obstacles to overcome. So I made a point of hiring females, and I think I did the right thing for sure, in the sense that by a third of my scientific force was female. But in terms of the security aspects, obviously now in my day, if you left the document out and it was a security infraction, because the guards would come by, we had a clean desk policy. But somebody forgot, and here was a document that he had in the lab because it was a data book and it's marked cleared. They came back, and our wonderful Ed Young, our security director, came up with the idea of putting this 8-ball on your desk in the morning, which is about, sort of a stigma kind of a thing to remind you that, I don't remember, 3 security infractions or something, and you were out the door. So there was, the biggest problem with that was obviously for my secretaries and all of the administrative staff there who had to take care of and file. You meticulously had a form to fill out with each document and so on, so if you destroyed it, you had to destroy it. The other aspect was that of the plutonium security. We used to call it, we used to have to know where every plutonium atom was, so to speak. But we had, in my case, we had scientists who were doing small metallurgical samples or tensile bars. I mean, that's part of our thing. We would do microprobe samples, chemical analysis, stuff like that. And you had to account for all of that. And I think you probably know that there was something called the materials unaccounted for inventory that you did, I don't remember, once a month, whatever. But you had a very small tolerance, so that if one of your engineers forgot he dissolved this or tensile bar that in acid or something for an analysis, and he didn't list it and we didn't get it, we got back very quickly, where is this, and how, you know. So that added a lot of time. The other aspect of it was because we were in Dow Chemical, and even to some extent in research in Rockwell, engineers are engineers and scientists are scientists, in the sense that if we had an experiment going, people would come in on weekends or night. On the security aspect of that is, you would have certain alarms. A vacuum pump might fail or something. You had your name right there, and the guards would call up and say, there's this red light flashing, you know, get out here now. What does this mean? You know, and you tell them it's a vacuum pump. Push the left button and that'll stop that, or that it might be something and you had to go out there. You don't see that here, is obviously outside. You have down here the different environments, particular experiences. I was not here for the 57 fire. 1969 fire, building 79 is adjacent to 77, 78, and so on. There was a corridor and an airlock. Our engineers and we used to have to walk through there to get down to 71 building, where I had a few personnel and staff members or bringing up samples in exchange. So you walk through that corridor and through the production. At that time it was the forming area and so on. I was presenting a technical paper, a scientific paper, at a conference in Pittsburgh. And I left Sunday afternoon, flew out to Pittsburgh, and Monday morning or so, I called my office just to check in. And my secretary was talking, I instantly knew, through a respirator. And I figured, oh, blank, you know, this is, something's wrong. And she said there's been a fire, etc. So I called my supervisor, and he said, yeah, there was suspected contamination came up from the smoke into the 779 building. And so if it was, they had to decontaminate the entire building, the laboratory, etc. And I said, well, do you want me to fly back? He says, why? All you'll do is end up helping to clean, get your paper presented, and so on. Turns out that after that, when I came back and so on, the thing was to, at that time, was to get those buildings back in production. Now, it turns out our area was not contaminated to any extent, but the airlocks had worked just as they're supposed to. But the point was that afterwards, we were asked to volunteer, and we did. As a group, we volunteered to go in and help clean up those buildings. And I recall you got into a full gear with a full face mask, etc., and climbed up scaffolding to, in some crevices we actually used a little toothbrush to scrub and make sure, you know, obviously monitoring and going back and making sure that the area was clean. But again, in one respect, that was the attitude, and I had no problems. Even my secretary volunteered to do that at the time. It was just considered everybody pitch in and help. So even though we weren't directly involved, not in that operation and so on, we did help with that aspect.
So what was it like to go into that building? What was it
Well,
like after the fire?
Other than some of the damage you could see because they were just removing some of the Lexan and plexiglass. I think it was, in one sense, it's eerie because now you're in full face, which of course we didn't work with normally. And all the monitors, the very careful, stringent aspects of it. We were also, of course, involved in some of the metallurgical analyses and aspects of it. So in that sense, you had the aspect of, what happened, don't let this happen again kind of a thing. What can we do in terms of providing analytical support to see what happened? I think you know that, one of the things that happened was you had one of those left-hand, right-hand safety things where the extra protection you put in for radiation to cut down on the radiation back there also prevented the heat detector from detecting it almost quickly. In our labs, we had heat detectors everywhere, in all the glove boxes and so on. But in this place, they had, because the larger quantity of plutonium, they had put, it apparently delayed at least the detection of the fire when it started. Protests, we figured that. I was very aware, the media. In one sense, there's no question, there was a difference between people who were just afraid of the word nuclear or radiation versus those like the chemist from CU. He did indeed do the first analysis, found there was plutonium in the soil. I think on our side of the plant, the R&D side, the engineering side and so forth, we recognized that immediately, that what he did and how he did it and so on was accurate and scientifically correct. And so you go back and obviously now you're starting to do chemical analysis of the water, everything that's on the outside. So that was a response. The failure was that we didn't go out beyond the buffer zone, not we, but the environmental people that we had at the time, and did those analytical things. And then there were those people who just don't want anything to do with, and those protests were, I would say at some point, maybe annoying rather than, because you wanted a dialogue, and the people who were doing the chemistry and so on, and people who said there are more brain tumors in Arvada than there were, that sort of a thing, that we felt was a little irresponsible, and it proved to be. How did I feel when the production stopped? Well, that I think was unfortunate. In one respect, I think it's certainly with after the Cold War that we certainly didn't need that level of production, that kind of a facility. I think because of the need to maintain the weapons, because they do, it's like metals, they corrode, they deteriorate. That if you are keeping if the strategic thing, because of the global uncertainties, that you have a core of response, then Rocky Flats would have been very useful in a downsized way, considerably, in terms of being able to do the retrofitting, the surveillance that was necessary, and so on. That task has now fallen to some extent down to the Los Alamos National Laboratory, and their expertise is in the research end and not in really making weapons and so on. In fact, it's obvious because DOE has just issued a request for proposals for contractors to run this, and the stipulation is that the plutonium, the aspects TA-55, those buildings that are involved with manufacturing, will be run by an experienced industrial contractor rather than the University of California. And of course, lots of Rocky Flats people went down to try and help. So I think, but in terms of the cleanup, no question, I think that that's a good thing, in the sense that once a decision is made to stop production, the plant has no mission any longer. It isn't quite suitable as a commercial park or anything like this, research park. Then the thing to do is to turn it into what it's going to be, preserved. I, of course, was one of the founding directors for the Rocky Flats Museum and involved in some of the things. I would like to see some public access, certainly. I would have loved if they kept the water tower, because that would be the only thing left standing and it wasn't involved with contamination. But so yeah, I think the cleanup is being done responsibly. And I had an interesting aspect in, I retired from Rocky Flats in 1992 in plant training and came here to Colorado School of Mines. I had the opportunity to go back and visit Building 779 after they had deconned it, had cleaned out, and it's surprising how different it looks once all the temporary plywood office doors and partitions and everything else. You expect the glove boxes, of course, to be gone. It's just a big empty room. But you don't realize that all those offices were just partitions, and now you just have this long corridor of nothing. You know, my office used to be there, and Clint Heipel's used to be there, et cetera, and so on. That, I think, was kind of a memorabilia, bring back a number of memories and so on, walking through that. And that was just before they demolished it. Safety, security issues we've covered. Colleagues at work exposed. Of course, we worked with those materials. A lot of my papers were published on the physical metallurgy and joining of beryllium and so on. We were very aware of the hazards associated with those materials. One aspect is the plant, again, had the best criticality lab in the world, period. These were scientists, physicists, who did experiments safely, but then were able to extract that knowledge and say, no, you can't put this pit and that bottle of water over here and that such and such. The idea was you had to make it 3 goof-offs before you got into a serious situation. So, and they were very, very sharp on criticality infractions, we called them. So before we did an experiment, we'd call in one of these experts from the criticality lab and say, look, this is what we're going to do, and we're only going to use 200 grams of this and so on. And so that part was very, I mean, we never had a criticality accident. We never had a fatality, I guess, except for an electrician who inadvertently touched some high voltage wires. So nothing from that aspect. The contamination issues, well publicized. So, and that, you know, in hindsight and with today's technology wouldn't be as much of a problem, obviously, as Los Alamos and Livermore are demonstrating.
Were there people in your group who were exposed to contaminants?
We did not have any body exposures in mind. Again, we were working with smaller groups. And this is in the days in Dow, is if you spilled something, you cleaned it up under the supervision of a monitor. That cut down a lot. The incentive was, I'm not going to be scrubbing the floor and everything around me and so on. So they were very careful. And again, being an R&D group, we didn't get into the quantities and the level of exposure that somebody might have in the manufacturing side. And then again, I moved up. One of the things that I wanted to mention was as I promoted in different aspects of when I came back to Rockwell, I was asked, I was a deputy to the they changed it to research and engineering, the Rockwell thing, and not development, but engineering. I was a deputy to the director at the time, and Rockwell was very much in a community-oriented, I mean, they came from California, so they knew the importance of speakers bureaus, they knew the importance of things. I did a lot of what we called lunchtime kind of analytical thing on archaeometallurgy. So we would have a metallurgical analysis of a Hopewell Indian copper ear spool, or artifacts that somebody would send us and things like this, because we had the best equipment in the world for analysis. And so we would help in that respect, and those were some of the things we did. But after that, I was asked to be help, and my office at that time was at the wind energy. Rockwell started up the wind energy site, and I moved out there so that I could interact with off-site people without the necessity for clearance and so on. And our community thing was that we were trying to help industry in the Colorado, and also students, and provide more engineering students. So Representative Skaggs helped us get a bill through Congress, and Rockwell and a number of other industries met in my office and started up what was then Colorado Advanced Technology Institute. And that was a consortium. It involved all 4 research universities. I would provide seed grant to faculty members to do some industrial research, stuff like this. The photo up on the wall is the signature of Governor Lambs to do that. While I was here, director of this Colorado Advanced Materials Institute, Rocky Flats was announced it would shut down. The surrounding communities, Arvada, Boulder, etc., formed what was the Rocky Flats Local Impacts Initiative, which you may know about. And their idea was, how do we mitigate the economic impact of shutting down and laying off 3,000, 6,000 workers, something like that. And my aspect of it was, I won a competitive DOE grant for $2 million or so, that we would provide technical support from a faculty researcher who might have some unique equipment to an entrepreneur here in Colorado and a surrounding area to help him build a prototype, get it to commercialization. So we would provide these competitively. So somebody would come up with an idea, say CU Boulder had a number of them, and they would match up with a faculty member they knew was interested in the research. They'd come in, make a presentation to us, and we'd provide $100,000 seed grant or $75,000 for a year. That provided a student to help the entrepreneur, got some interaction between students and startup companies in the area and so on. Very, very successful program. That was, I think, one of the best community things with the Rocky Flats Local Impacts Initiative. Rifley had a director from Boulder and a director from Jefferson County, and so they integrated all of the aspects of this. It later became other entities in monitoring Rocky Flats. That was what do you think were the best things about working with Rocky Flats? The people, no question. I'm sure that a number of people would tell you that. You think back, and again, it's in the period we're all enthusiastic from my standpoint as scientists and engineers, and no one else is doing this research. I mean, to do this under difficult times is something else. The research that we did, and you'll see some publications up there in books and so on, but was very unique, still is utilized. It's incidentally, as a transfer of that, here at Colorado School of Mines, we now have a surrogate nuclear materials thing whereby we substitute other alloys to try and demonstrate what the nuclear materials behave in terms of alloy and metals properties and so on. And we have a number of graduate students from Los Alamos, and one got his PhD from Rocky Flats here, so that we could work safely without all the hazards of and security requirements and so on. Now, memorabilia, would you like me to show you some things?
Sure.
Okay. On one aspect, again, because I worked at the Smithsonian Institution and have an interest in archaeometallurgy and whatnot, when I was a founding member of the board for the Rocky Flats Museum, my aspect and interest was to go and see what archaeological artifacts, if any. Rocky Flats was not a Paleo-Indian site or anything like this. It's been well surveyed by professional archaeologists in the State Historical Society. There are a few sites at Rocky Flats that have been designated just because they are historical or some artifact was found there.
What's your,
yeah, let me
have your microphone, so just be careful to not get to it.
Don't want to go too far, huh? Okay.
Okay.
There was a site that's designated as 5JF474 in the National Archaeological Registry. It was an old general store out in the buffer zone. And the only artifacts of note, and my task was to catalog those, and I had a student and I go through there's probably a couple hundred artifacts, but unlike there are no arrowheads, none of the kinds of things you associate with, but archaeologists collect them anyway. And so this is the archaeologist who's doing it's now a road, but at one time it was a general store. And I don't remember the dates exactly, but turn of the century, 19th century kind of a thing. So what the archaeologists will collect is things like ceramic pottery fragments, which are obviously in the store, glass fragments, nails, which can be analyzed to determine what their composition is, so forth. Not of interest except to maybe state archaeologists in one sense, that there was this building well before Rocky Flats, during the days of stagecoaches and so on. This will go to the Rocky Flats Museum when they have an adequate facility to display and so on. There's a box mostly full of barbed wire. Barbed wire was obviously big back in the days before the church ranch, and it's probably the predominant thing in there. So that's one interesting aspect. I mean, you look at Rocky Flats, think about it, over a couple of hundred years, in terms of the 19th century, where it was basically grassland, a few longhorn cattle, a stagecoach stop, some runoff streams, and here in a year or so it will be almost that again, just prairie grass, the deer, the antelope, etc., and so on. So it's an interesting, because it's one of the features perhaps in history where you went from in a cycle from this bare Rocky Flats kind of a thing through a very, very sophisticated, controversial production facility in the Cold War, and now is reverting back to what it was back when a few Arapaho and other Indians would have been roaming it.
With some concrete caps, right?
With some concrete caps. That's right. That wasn't there. I agree with that. Just the big boulders. What else?
Well, I have a bunch of sort of holes I'd like to fill. If we could just sort of maybe start from the beginning again, and I'll just ask you a few questions if that works for you.
Sure.
First of all, when were you born?
Oh, 1937. I'm a Depression baby. As I said, my mother got out just before the Nazis hit in 1936, so I was a natural. And so I grew up in this little steel town. And my father worked for what was then the Carnegie Illinois Steel Company. Mm-hmm. So I'm still fascinated with this Carnegie connection. So when you said there's a Carnegie Library in Boulder, I have to see that facility.
Oh, it's a great building. And I guess the other thing I was wondering is if you said that you had worked in the steel mills and that convinced you that you didn't want to do that sort of labor. I wonder if you could describe that experience a little bit.
A steel mill in the 50s, and understand, I graduated from high school, and Duquesne Works, instead of giving us fellowships or scholarships, they decided they'd let us work as laborers in the steel mill. And the first job, honest to goodness, was we were essentially sort of like lumberjacks and brush clearing crew out on the steel mills in the Pennsylvania or in the Pittsburgh area were interconnected in terms of power supply. So you would have a high voltage lines running from one steel mill to another, and you would have to keep that clear of brush, just as public service or the companies have to do today. So we went out there and we weren't allowed to have chainsaws because they felt that was too dangerous. So they gave us axes and broad brush hooks and everything else, which looked like medieval weapons instead. I always thought that was amusing. But to work in the steel mill exactly, there are a couple of things that come out that are quite different. One is the noise level. Two is how much more dangerous it was back in the 50s than anything I've ever experienced. I mean, it would be simple. Somebody would be at the top of a blast furnace, a bricklayer. He happened to push off a brick. It falls 100 feet. The brick weighs 11 pounds. F equals MA goes right through the hard hat of the worker below. And these were, you had a fatality or two a year. This is unheard of, although it's still the same in construction industry. So I thought working at Rocky Flats was relatively safe. Or in another instance, the old timers would bring their coffee from home in their little lunch buckets, and they put them in mason jars. The wife would put them in and sort of keep it hot in that. Didn't matter. But one of these individuals left it in a ladle, and after he finished lining the ladle in brick, of course, when the next tap came through, crane brought over the molten steel, dumped it into there, and just that little bit of water blew the roof off that building.
Wow.
The amount of steam generated. There are lots of stories like this. I was standing in a, you feel. The other thing is the heat. We were put into soaking pits which have no water in them. They're actually gas fired to reheat ingots so they can go into a rolling mill. You go down, eventually that brickwork breaks down and deteriorates. So you are down there and you're in all wool, because wool doesn't burst in the flame. This is before aluminized or asbestos suits and so on. You're in all wool, you have a respirator, goggles, hard hat, and you're with a jackhammer on your knee, working to knock down this old brickwork that has to be replaced. And while they poured water on this to cool it down, that got the exterior. As soon as you knock that first level down, you get this blast of heat at you, and that told you might not want to do this for a living. Or you could feel heat on the back of your neck. You turn around and here'd be an old tiny little train that was carrying these red hot ingots from one facility to another. Steel mills, I'll never forget, I took my kids down to CF&I in Pueblo when back here when they were young, and my daughter still is traumatized by all the sparks going out. My wife, I remarried 2 years ago, and I took her down, and it's now a modernized mill, but still we walked over grading with red hot billets coming out of a continuous casting operation, and she looked down once and just tore off for the other. She said, that was like walking over the Temple of Doom scene. She said, how do you do this? And I said, oh, no, people do this for a living, but that's why I'm in academia. I retired in 1992, retired from Colorado School of Mines as the director of the Colorado Advanced Materials Institute in 2002, and I'm now acting director of the Office of Technology Transfer, and this is a fun position too, because I get to help people with patents and the intellectual property as I did. So, you know, in the bottom line of, I think certainly Rocky Flats played an extremely valuable part in the Cold War. You can debate about, as people do, about dropping the bomb in Hiroshima, but you can debate any number of things in the fact that you need nuclear weapons. From, I think, middle class of America, you'd like to have some, but you don't want it certainly proliferated, and you don't want it to be at the capacity that we had to have back then. What other questions?
Well, I'm wondering when you first heard of Rocky Flats. And
Actually, as an advertisement, when I was looking for positions in at Ohio State, you're a graduate student, you figure I got to feed the wife and kids now instead of vice versa, and I need to start interviewing for positions, and they had advertised for a position that fit my expertise in electron microscopy and physical metallurgy and so on. So that's when I heard of it. I didn't see it until I flew out here for an interview. And the interview was funny because, as I said, they couldn't talk much about what they were doing, except they're candid. You know, we make components for the nuclear weapons complex, and we have a joining group, we have a physical metallurgy group, and they do, et cetera, general terms. They took me out to Arvada. You remember, it was a very small town in 1965, and there were new houses being built on Ward Road. So we spent the afternoon touring the housing. As you know, here's where you can move. This is the kind of a house you could afford. You know, I'm coming out of graduate school and thinking, I can't afford this house. You know, my God, it's $20,000. So, you know, that was the other aspect. You had a question on here about what was it like not to tell your family about what you were doing. Again, because a lot of our work was unclassified as research. Then certainly, you know, my wife, who's my ex now, but she was very intelligent and knowledgeable about science and engineering, and so we just didn't talk about, you know, the types of weapons or stuff like this. Let me add one thing I forgot to add. Do we still have time?
Yeah, we have. We can take another hour. We have plenty of time, and we have.
The one you might be interested in is I was going to talk about. When I was a deputy director, assistant to adjunct to the director for Rockwell in research and engineering, we had an incident with what was then called the model shop. And the allegations were that the manager of that group had used the company facilities and staff to build things for them, a wine press and so on. Much of it actually were trophies and mementos, etc., for the laboratory directors and so on. Who, if we did something, they'd make up a plaque and extravagant and so on. But the other part of it was that he was doing stuff for his home. So they arrested him, got him off plant site. There was a grand jury preliminary investigation into the allegations, but he died before anything went farther. In the meantime, my director said, we need this situation corrected. I mean, it's an embarrassment to Rocky Flats, etc. And Fred, you're very capable. And I said, sure, I'd do it. So I took over the model shop and a small group that was called the Laser Target Fabrication Group, IF. And the model shop consisted of some individuals who were artists, engineers. I mean, we had one who could airbrush anything. The machinists and so on. It was in a vault in 881. I mean vault. And the key to that was they fabricated the training models using surrogate materials of the actual weapons that the military would train on. There might be a cutaway. So you'd see the pit, you'd see associated components, you'd see the warhead assembly, everything. When we had models of the actual warhead with a cutaway showing the insides of it and so on. They sent me to Sandia Laboratories and sat with military staff who would, mostly enlisted men who would be asked to handle nuclear weapons and so on. I mean, it was a James Bond type of thing. That facility was the only one that had clearance for, that little vault. And I was one of the few people who had clearance for the entire weapons, to see an entire weapon. And we would send these to the museums, classified museums in Los Alamos, Livermore. One of our models ended up in the White House, where Reagan had it in a classified situation, saw what it was, and so on. So it was very important, and the people there were extraordinary in the sense of skills. I took them to the museum because we would also produce dioramas, the small-scale models for the museums in Los Alamos and Livermore. So you might have a Star Wars display or something, because we were involved in some aspects of that back in Reagan's area. And you would have, you'd make up a model, and the one engineer would take, what engineering drawings look like. They're flat and two-dimensional at most, and he'd airbrush out an artist's conception, so it would look like something that belonged on Time magazine or a science fiction aspect. And he did it accurately, so that it represented everything to scale and the materials. As a result of that, I went down to the Pantex plant and actually saw the assembly, because the specifications for these models were such that the material that you used, whether it was cardboard or foam or whatever, had to look exactly like what it would be in a real weapon. So if you had metallic sheen, we had to have a metallic sheen, so on. Anyway, the other aspect of this was the laser target fabrication. There was an inertial confinement fusion program where you take a small target and theoretically you fill it with deuterium and some other things. You hit it at all sides with either a laser or some other type of energy, compress it down. So it's almost like a miniature nuclear weapon. And the justification for the big program they have out there now is that they can do simulation without ever testing.
I'm going to stop you.
Okay.
Okay? We'll just